Hi, this is Siddharth Singh, and today we'll perform an experiment on network security. So, the objective or aim of the experiment today is to study the role of firewalls in providing security to public shared networks like the internet. Now, we know computer networks are typically a shared resource which are used by many applications for many different purposes. So, the data transmitted between applications are visible, but sometimes the application users do not want that this data is can be viewed by other people. So a firewall router is used in this scenario. So a firewall router is a special programmed router because it does the work of a router, that is, forwards the packets from the source to forwards the packets, but it also does one more thing, that is filters the packets. So basically it's configured with a table of addresses characterizes the packets that will be and will not be forwarded. So we'll start off with it. So we set up a network. So we deal with two scenarios. First is the no firewall scenario, and the second is the firewall scenario. So initially in the no firewall scenarios, from the object palette, we make the following configuration. So we choose three Ethernet slip 8 gateways. Now these Ethernet 4 slip 8 gateway, they basically represent, this node model represents an IP based gateway supporting 4 Ethernet hub interfaces and 8 serial line interfaces. So IP packets arriving on end interfaces are routed to the appropriate output interface based on the destination IP address. Then we have the application config, which consists of applications, and we can also group applications like the email, FTP, databases, etc. We have the profile config here, which represents the different roles or departments. Like for in an office or for a corporate, it can be sales, marketing, engineering, research, etc. So that's the profile config. Apart from that, we have the IP32 internet. So IP32 cloud node models. It represents an IP cloud supporting up to 32 serial line interfaces at a selectable data rate through which an IP traffic can be modeled. So here's the IP. Next you have an IP32 server. So this, apart from that, we'll have server. Basically we'll handle all the server load and we will get traffic from the server. Apart from that, we have the configuration um, as the triple P workstation. The triple P workstations, that these represents a workstation with client server applications which are running over TCP/IP or UDP/IP. Workstation supports one underlying slip connection at a selectable data rate. So after we make this configuration, we connect it through the triple P DS1 links. So the SLIP is serial line internet protocol connection at a selectable data rate. Triple P DS1 links I used to connect them. It's running triple P. The data rate offered is 1.544 Mbps by the triple P DS1. So we start the configuration. We right click on the application, edit attributes. In the application definitions, we choose default. After that, we apply to the selected nodes and OK. Similarly, for the profile, we edit attributes. In the profile configuration, we take the sample profiles and apply to selected attributes and OK. Now in the server, we edit attributes. So in the applications and the application supported services, we will choose all. So in the application services, we choose all. So basically, we are configuring all of the applications, the 24 applications offered. Now in the sales A, we would select similar nodes that are both of them. We edit the attributes and we go to the application supported profiles and we set the rows to 1. That would be the salesperson. And then we click on OK, I've done it. And we save the project. So now right click on the workstation, choose individual statistics. Now here, whatever the parameters we need to collect to analyze at the end. So we choose DB query response time in seconds, and we also choose the HTTP page response time in seconds. Then for the sales A, again we go to the choose individual DES statistics, discrete event simulation, and in the node statistics we choose the client HTTP traffic received 10 bytes per second and client DB, that is the traffic received in bytes per second. These are the parameters. We do it the same for sales B as well. Now it's time to duplicate the scenario. So we duplicate a scenario and create a firewall scenario. So here we create a firewall scenario. Now this configuration is very much similar to the previous one, only here we have added a new node. So we can just set name as Odyssey. Okay, we set name. But this is the, so here we use an Ethernet 2 slip 8 gateway firewall. So here we have a firewall which would help us filter. So this node model represents an IP based gateway with firewall features and server support. It can be called as a multi-home server firewall node. So it supports 2 Ethernet and 8 serial line interface at selectable data rates. So we have a firewall which would now filter the packets. So we edit the attributes and we go to the proxy server information and we expand the row 1 which would be the database and we say proxy server deployed equals to no. So yeah, apply to the selected objects. So basically we are not allowing the traffic from the database to come. After that we need to run the configuration for say 5 hours, duration would be 5 hours, and we run the configuration. Also we run both of the configurations, both scenarios for same duration of time. Now after doing that we go to the DES results and compare results. For the current project will analyze both for firewall and non-firewall scenario. We analyze the DB query response time. So we see this is the DB database query response time, the global statistics. We'll see the HTTP for both of them. We'll see the HTTP for the firewall, non-firewall scenario same, because the firewall is blocking the traffic from the database specifically. Now if we see the object statistics, the individual, for the sales A, yeah, we see the no firewall, they have a lot of traffic due to the client DB. But in the firewall scenario, there is absolutely no traffic. So in the no firewall, it reaches up to 20, near 20. The peak is there. and the minimum is 0. But here you see the no, in the firewall scenario it has blocked the database traffic, so we have low traffic. And if you see the HTTP, there is traffic for both of them. Similarly, we can analyze sales B. Here we see that the no firewall again has a lot of traffic, but the firewall is filtering out the database traffic, so it's absolutely 0. The traffic received in bytes per second, where x-axis is the time and y-axis is the traffic in bytes per second. And lastly, in the sales B, we analyze the client HTTP request traffic. So here again, traffic is in both scenarios because the file was blocking the database traffic. We see a lot of traffic with the peaks rising, and this is the minimum or 0 traffic. That's how we analyzed how the firewall is filtering the traffic. In this case, it's filtering the database traffic. So in the no firewall scenario, there is a lot of traffic, but in the firewall, it's blocking the database traffic, hence less or 0 traffic. That's all for today. Thank you.